Hey, welcome back to the problem where I said I was going to do on the last video and then I didn't. Whoop whoop. The Great Plains Railroad is interested in studying how fuel consumption is related to the number of rail cars. Where's my context? For its trains on a certain route between Oklahoma and Omaha. A random sample of 10 trains on this route is yielded the following table, so the number of rail cars and fuel consumption in units per mile. A scatter plot and the residual. And the output from a regression analysis are shown below. So if you remember, the way it works, residual plots, is that if you draw the line of best fit, it's going to look something like this, where if you turn it sideways, then you can see it's below and above, then it's below and above, then there's some above it, and then there's the two above it. Basically, if you take this line and shoot it that way, that's going to be what it looks like. That's how regressions work. Anything down here would say that the observed was below the predicted line. So this is the predicted line. So the points below the predicted line, points above. Below is obviously negative residuals, and above is obviously positive residuals. So that's what's going on there. Okay, is a linear model appropriate? So just kind of looking at it, yeah, I'd say it's good. It looks good on there. When you look at the residuals, this is actually where you're supposed to look on the residuals. Do you remember why? Do you remember why this is going to be good based on the residual plots? It's because it is scattered. There's no pattern, right? It's not like above and then below and above or opposite. There's no pattern. It's just. So, is the linear appropriate? Yes, it is. It's going to be based on the residual plot. You might be tempted to use the R value. Remember that R value is basing things on whether it looks linear, but technically you could have, like, the residuals are very close to the line, but they still show a pattern. It's the fact that these are random that makes it a good linear fit, not that the fact that the residuals are very small. So just write that. Is linear? Yes, it is. The residual plot looks random with no obvious patterns. If you want to mention the R, I'm sure that would be fine. Additionally, the R squared value is 0.967, and if I really want to be an overachiever, 0.967, I always forget that it's the square root of 0.967. That would be the R value. So the R value is 983. So R equals 0.983, which is a very strong linear correlation. I don't know. Very is subjective. Maybe I won't put it just in case, but most likely the first part there is going to answer the question good enough for the essentially correct E. And then the second part is just, good stuff. B, suppose the fuel consumption cost is $25 per unit. Give a point estimate for the change in the average cost of fuel per mile for each additional railroad attached to a train. Oh boy. Let's see. Where's our fuel consumption equals this times the rails? Okay. Give a point estimate for the change in average cost of the fuel per mile for each additional. So that's going to be talking about the slope. The slope is change. Yeah, so change is the same thing as slope. You know, rate of change. That's the definition of slope. So it is talking about the slope, which was 2.15. So, you know, as you increase one rail car, just thinking out loud, as you increase one rail car, well, maybe I'll write it down. One rail car increase means on average a increase.
This ends Rise Read. Teachers, please be aware of students that leave
Fuel
your
consumption
classroom.
units per
Make
mile.
sure that they don't owe you work and have a valid reason for needing to use the library. And no more than one person is allowed
And it's
to leave
25
their
per
classroom
unit.
for the library. Thank you.
So that's just going to be probably multiplication. I mean, 2.15. So 25 times 2.15. Is 53.75. Okay, give a point estimate or single value for the change in average cost per mile. So, you know, it already says per mile there, so per mile is fine. That's it. I didn't use the 10.7 up here because that's just like the intercept. That's like if there were 0 rail cars, then it would just be the engine. Talking about that. So that's not really going to change much. This is just the change rather than the total. That was me showing my work, I guess. Okay, there you go. Awesome. Interpret the value of r squared. R squared is supposed to show you the change in variance or variation. This was something in the notes that's like, make sure you're writing this exact kind of thing. Interpret the value of r squared. I even wrote it on my handy dandy sheet over here when I started doing it. Value of r squared, proportion of variation. This is the thing that you're supposed to do that. In this one, it was a 96.7%. Okay. So 96.7% of the variation in, what was the Y? Fuel consumption? Is being accounted for by the regression, so some way of saying that. I think on the sheet I said explained by, but either one of them's good. I'll just write explained by because that's what we did. The regression excuse me, of the two variables, right, is being explained by the regression of, I always forget, what are they? Fuel consumption in rail cars. Of rail cars on fuel consumption. Okay, that's it. It says in the context, I use the rail cars and fuel consumption for context. Interpreting, it says that it's explaining 96.7% of the variation. So the interpret was this. Context was making sure I said rail cars and fuel consumption. Okay. Would it be reasonable to use the fitted regression equation to predict the fuel consumption for a train on this route if the train had 65 rail cars? So what I'm gonna look for is if 65 is inside of our data set, because remember, if it's within the domain or range of values that we were given, then it's most likely going to be fine, assuming it looked linear, which it did. But if this is really out far of the range, then that would be extrapolation, and we'd have to write about that. So, over here, those are the residuals. Number of rail cars. It looks like it goes up to 50, which means 65 would be like here, up there. That's going to be a big no. I'm not going to do that. That's way too far out. That's going to be extrapolation. I mean, like, what if this was curved? If this was curved, then it would have curved up here, and all of a sudden it would have been up there, right? So you don't want to do that. That's going to be extrapolation. Do make sure you are writing the word extrapolation. Extrapolation. You need to write it down somewhere in our thing. Would it be reasonable? No. Explain. 65 is not in the range of values we observed. So it would be extrapolation. There also, in addition, there isn't a good reason to assume the regression line, I don't know, the predictions would continue, or prediction line, or prediction would continue. Something like that. But the big thing is, once again, making sure you say no, make sure it's due to extrapolation because it's not in the range of values. By the way, when I say range of values, I feel like some people might ask this because sometimes in class I've been saying domain. Please note that when I'm saying range, I am not talking about Y values. Like the range is like, from 20 to 50, that is a range of values, right? I'm not talking about domain and range like you're used to in Algebra 1 or something. A range of values. So 65, right? 65 is not in the range of the numbers. It went from 20 to 50, so 65 is not in this range. But since we call it, this is on the x-axis, it's also technically in the domain. So that's why I'm saying either words. Either one of them would work for you. But I wanted to explain that in case someone was confused by it. Okay, I think that answers it, right? Would it be reasonable? No. Why? Because of that. Interpret the r-squared value on this percent of the variation, and this is explained by the regression, right? In the regression of rail cars and fuel consumption. What is the change? It would change to be that. Show your work, fuel consumption, give a point estimate, which is a single value. So that looks fine. Maybe I'll just put like per rail car added or something. Is it linear? Yes, because of the residual plot, no patterns, it looks scattered. Okay, that looks good to me. All right, hopefully this was useful to you. Take care, and I'll see you later.